we are told that f is a periodic function with a period equal to 7. And you can see this function f repeats itself. The first cycle here shown in red starts at 0, and by the time we get to 7, it ends. And then it repeats itself. Notice that f of 7, meaning the y value when x equals 7 equals 0, and f of 14, the y value when x equals 14, is also 0. That's because one period has transpired. So you're going to get the same y value one period down the road. Now, folks, if we talked about the domain of this function would be all real numbers greater than or equal to 0. However, when we talk about reference numbers are limited to the first cycle. So for the reference numbers, it would be all real numbers between x equals 7 and x equals 0, namely the first cycle. Now, very important, the more distal value is not included. So we make that a less than sign only, but here the 0 value is included. So the reference values are all values between 0 and 7, but not including 7. It's very, very important. That's because 7 becomes the new value of the second cycle. Next, we are asked to evaluate the following, and we're asked to write the answer as f of a reference number. So here we've been given inputs that are outside the reference values. The reference values are between 0 and 7. So what we need to do is say to ourselves, okay, they want to know what f of 10 equals. Well, f of 10 is going to be out here somewhere where x equals 10. The question is, how do we get into the reference zone? The answer is you can only move from out of the reference zone into the reference zone using multiples of the period. So if we're outside, if our reference zone is between 0 and 7, and they gave us an input value of 10, we need to get into the reference zone. But we can't just go willy-nilly and jump in here. We have to move into the reference zone using multiples of the period. So in this particular case, if we moved in 7 units this way, that would be enough to get us into the reference zone, and it would be 3. So f of 10 is going to be the same as f of 3. So if you look at it on your graph, f of 10 would be somewhere around here. That's y value about right there. And if you move to f of 3, it's going to have the same y value. That's the idea here. Okay, let's now look at f of 21. F of 21, again, is outside the reference zone. The idea is to get from 21 somewhere within the reference zone. So we're out here at 21. Now, 21 times 7 doesn't get you in. 21 minus 14 gets you to 7. But folks, 7 is not a reference number. Okay, let me be clear. 21 minus 7, okay, that's one period, gets us to 14. Now we go another period, another 7, we're at 7. That is not a reference number. So now we have to go another 7, and we land on 0. 0 is a reference number. Now, why are we moving in multiples of 7? Because that's the period. The period is what gets you to the same point in the opposite cycle, or in the cycle to the right or to the left. Let's go ahead and do the last one. We have f of negative 16. So negative 16 is clearly out of the reference zone. So here's negative 16 here. We'll put it on the left. Here's our reference zone between 0 and 7. Will positive 7 get us in the zone? Answer no. If we add 14, will we be in the zone? Answer no. If we add 21 to negative 16, we will be in the zone at positive 5. So f of negative 16, when we add 21, puts us at 5. Therefore, these two y values will be the same. Next, we have f of negative 4e. Negative 4e is approximately negative 10.84. Okay, clearly we are not in the reference zone. The reference zone is between 0 and 7. We are at negative 10.84. So it's clear we have to add 14 to get into the reference zone. Now, when you write your answer in this particular case, it's okay to just do it like this over here in pink on this side. You could say the reference zone would be negative 4e plus 14. That is an adequate answer. Okay, let's look at 3 pi. 3 pi is going to be out of the reference zone because 3 times 3.14 is going to be greater than 7. Okay, so here we go. This is the same thing as saying f of approximately 9.42. Okay, 9.42 is out of the reference zone. The reference zone is between 0 and 7. We're out at 9.42. It's clear that if we subtract 7, we will be in the reference zone. So it's okay. It's accepted practice to leave your answer as f of 3 pi minus 7. Next, we are given f of 210 and asked to rewrite this as f of a reference number. Our reference zone is 0 to 7. We are way out here at 210. We have to move this way, but we have to do it in multiples of 7. So the most obvious one is 7 times 30, which is 210, and if we move this way, we will end up right at 0, which is a reference number. Next, we have 24 and 2/3. We are out of the reference zone. We're going to go ahead and write 24 over 2/3 here and ask ourselves, how do we get into this reference zone? Well, if we subtracted 3 times 7, so if we subtracted 21, we would get 3 and 2/3. So this is an accepted answer, or you could change that to an improper fraction. That's up to you. But these two values, f of 24 and 2/3, whatever that y value, is going to be the same as f of 3 and 2/3.